Okay, if you've ever built anything with React, you know it just feels fast, right? But have you ever really stopped to think about what's going on under the hood? Like, what's the magic that makes your UI updates so ridiculously smooth? Well, today we're going to pull back the curtain. We're going way past the standard interview answers to really dig into React's core rendering engine. We'll look at the myth and then the much cooler reality. Yeah, you've definitely heard of the virtual DOM. I mean, we've all been there, right? You're prepping for an interview or maybe just starting out, and you see this phrase everywhere, the virtual DOM. It's kind of become the go-to one-size-fits-all explanation for why React is so performant. But here's the thing. It's not the whole story, not even close. While it's a pretty good concept to get you started, the virtual DOM isn't really a specific thing. It's an idea. The actual engine driving modern React, oh, it's way, way more sophisticated. And honestly, it unlocks possibilities that go far beyond just being fast. So let's just quickly cover that common story, the one we all know. The basic idea is that talking directly to the browser's DOM, the document object model, is slow, like really slow. Every time you change something, the browser has to do all this heavy lifting, recalculating layouts, repainting the screen. It's a total performance hog. React knew there had to be a better way. And here's the classic comparison. The old school browser way, it's like redrawing an entire architectural blueprint from scratch just to move one single door. It's just wildly inefficient. So what does React do? It makes a super lightweight copy of that blueprint, our virtual DOM, and keeps it in memory. Now when a change happens, instead of redrawing everything, React just compares the new blueprint to the old one, finds that one moved door, and tells the real DOM to only change that one thing. It's a brilliant way to save a ton of work. Now that whole process, that thing that's actually comparing the blueprints, that's not just some vague idea. It's a real algorithm at the very heart of React. And it has a name, the reconciler. This right here is where the real magic is. And hey, don't just take my word for it. The React docs themselves say it perfectly. When we talk about the virtual DOM, what we're really talking about is the work that this reconciliation algorithm does. See the difference? The virtual DOM is the result, but reconciliation is the process that gets us there. So what is it really? At its core, reconciliation is a diffing algorithm, and diffing is just a programmer's way of saying comparing. Its one and only job is to look at the UI tree as it is now, look at the new one you want to create, and then figure out the absolute smallest, most efficient set of changes to make the old tree look like the new one. And the process is pretty straightforward, really. You do something, right? You call setState, a prop changes, whatever. React instantly creates a new UI tree in its memory. Then the reconciler jumps in, diffs the new tree against the old one, calculates the exact changes, and this is the key, applies only those changes to the real DOM. It's just an incredibly efficient system. But there was a catch, a big one. The original reconciliation algorithm, as fast as it was, had a major flaw. A fundamental limitation that could totally tank the user experience, especially as apps got more and more complex. So, just imagine this scenario. You've got a smooth animation that needs to run, a user is typing super fast into a search bar, and you're fetching data from an API, all at the same time. The old engine would just try to do everything at once. It had no concept of priority. And the result? You guessed it. Janky animations, a laggy UI, basically a terrible user experience. And the reason why is super important. The old reconciler was synchronous. That means once it started a job, it was all or nothing. It would start rendering an update and would have to walk through the entire component tree before it could stop. It was completely uninterruptible. It couldn't be paused, even if something way more important, like a user's click or an animation, came along. So, to fix this massive problem, the React team embarked on this huge multi-year project to completely rewrite the reconciler from scratch. And the result of all that incredible work is what we now know as React Fiber. And look, Fiber isn't just some small update or a patch. It's a total, ground-up rewrite of React's core. Its number one goal was to enable something called incremental rendering. In simple terms, that's the ability to break up the rendering work into tiny little chunks that can be paused, prioritized, and picked back up later. This is the huge shift in thinking right here. The old way was like a freight train on a single track. Once it started moving, there was no stopping it until it reached the end. Fiber, it's completely different. It's interruptible. Now, React can start working on a big low-priority update, but if you, the user, click a button, React can literally pause that work, handle your click immediately, and then go back to what it was doing.
It's an absolute game changer for creating smooth, responsive UIs. And this new interruptible architecture gives React, well, it's like it has scheduling superpowers now. It's not just about being fast anymore. Now it's about doing the right thing at the right time. So, what can React actually do with these superpowers? Well, like we said, it can pause work. It can even completely throw away work that's not needed anymore. Think about a user navigating to a new page before some data has finished loading. Why render it? And this is huge. It can assign different priorities to different updates. And it can even chop up a big rendering job into smaller pieces and spread them out over multiple frames to keep your app from ever feeling frozen. This is the bedrock that enables all the cool modern stuff, like concurrency.
And here's kind of what that looks like in practice. Fiber is smart enough to know that a silky smooth animation is way more important to the user's perception of speed than, say, rendering a list of data that just came in from the network. So it'll take care of that high priority animation first, making sure the UI never ever feels janky.
Okay, so this is all really cool deep dive stuff, right? But what does it actually mean for you, the developer, writing code every day? How does this connect to what you're actually typing in your editor? Well, the connection is way more direct than you might think. It actually all comes down to this. You know that warning you always see in the console, the one that yells at you to provide a unique key prop when you're mapping over an array? That's not just React being annoying. It's a critical, direct instruction that you are giving to the Fiber reconciler.
Yeah, think of keys like little name tags you put on each item in your list. Without those tags, if you add a new item in the middle, React basically has to guess what happened. But when you provide good, stable, unique keys, Fiber can instantly see, oh, okay, a new item was added here, and these other ones just shifted down. It lets React do a quick surgical update instead of re-rendering the whole dang list. Seriously, using keys properly is one of the best things you can do to help React's engine do its job.
And this really gets to the whole philosophy of React, right? We get to write our code as if the entire app re-renders on every little change. It's a beautifully simple way to think, but it's all a clever illusion. Behind the scenes, the Fiber reconciler is working its magic with all its fancy scheduling and diffing to make sure that our simple code results in amazing performance. So the next time you're in a conversation and someone mentions the virtual DOM, you'll know the real story. You'll know it's not just about a copy of the DOM, it's about a process called reconciliation, and it's powered by this incredible interruptible engine called Fiber. And understanding that, well, that's the key. Not just to mastering how React works now, but to understanding where it's going next.